Good day everyone. Today we will be discussing regression analysis, simple linear regression, and assumptions of linear regression equation. I am Jellian Paras and I will be discussing the regression analysis. Regression analysis is a powerful statistical method that allows us to examine the relationship between two or more variables of interest. While there are many types of regression analysis, at their core, they all examine the influence of one or more independent variables on a dependent variable. Regression analysis is a solid approach of determining which variables influence a particular issue. Regression analysis allows you to safely establish which elements are most important, which factors may be ignored, and how these factors interact. In order to understand regression analysis fully, it's essential to comprehend the following terms. Dependent variable. This is the main factor that you're trying to understand or predict. And independent variables. These are the factors that you hypothesize have an impact on your dependent variable. A set of statistical procedures for estimating relationships between a dependent variable and one or more independent variables is known as regression analysis. It can be used to determine the strength of a relationship between variables as well as model its future relationship. There are various types of regression analysis, including linear, multiple linear, and nonlinear. Simple linear and multiple linear models are the most common. Nonlinear regression analysis is typically used for more complicated data sets, with nonlinear relationship between the dependent and independent variables. This is the types of regression analysis. It includes linear regression, multiple linear regression, and nonlinear regression. The two basic types of regression are simple linear regression and multiple linear regression. Although there are nonlinear regression methods for more complicated data and analysis. Simple linear regression uses one independent variable to explain or predict the outcome of the dependent variable y, while multiple linear regression uses two or more independent variables to predict the outcome. The 6 steps to interpreting the result of a regression analysis are: first, look at the prediction equation to see an estimate of the relationship. Second, refer to the standard error of the prediction in the appropriate model when making predictions for individuals and the standard error of the estimated mean when estimating the average value of the dependent variable across a large pool of similar individuals. Third, refer to the standard errors of the coefficients in the most complete model to see how much you can trust the estimates of the effects of the explanatory variables. Fourth, look at the significance levels of the t-ratios to see how strong is the evidence in support of including each of the explanatory variables in the model. Fifth, use the adjective coefficient of determination to measure the potential explanatory power of the model. And last, compare the beta weights of the explanatory variables in order to rank them in order of explanatory importance.
Hello everyone, I am Joy Morong and I'm going to discuss about simple linear regression. Regression models, it describe the relationship between variables by fitting a line to the observed data. Linear regression models use a straight line, while logistic and nonlinear regression models use a curved line. Regression allows you to estimate how a dependent variable changes as the independent variables change. So una, dapat muna nating malaman ang independent and dependent variables. So sa independent variable, ito ay madalas nagpipredict or nagpo-forecast ng possible values ng independent variables. So maraming mga variables na pwedeng tingnan ang relationship at kung gusto nating malaman kung nakakaapekto ba ang variables sa ibang variables, then pwede nating i-run yung regression. Simple linear regression is used to estimate the relationship between two quantitative variables. So, pwede natin gamitin yung simple linear regression kapag gusto nating malaman kung gaano katibay ang relationship sa pagitan ng dalawang variables. So, halimbawa, the relationship between rainfall and soil erosion. So the value of dependent variable at a certain value of the independent variable. The amount of soil erosion at a certain level of rainfall. So let's have example number 1. You're a social researcher interested in a relationship between income and happiness. You survey 500 people whose incomes range from 15,000 US dollar to 75,000 and ask them to rank their happiness on a scale from 1 to 10. So your independent variable will be income and dependent variable will be happiness. So they are both quantitative. So you can do a regression analysis to see if there is a linear relationship between them. So another example, the regression analysis equation is being used to predict the value of the dependent variable. The said equation is defined by y is equals to a plus bx, wherein yung x dito is independent variable, y is the dependent variable, b is slope, and a will be the intercept. Ang gagamitin natin sa pag-compute ay yung formula nitong a and b at yung equation na y is equals to a plus bx. So let's have example number 2. A teacher desires to know whether the typing speed of a com-sci student in words per minute is related to the time in hours. So given the speed of student will be the x, and the corresponding time it will take for him to learn the word processing program, predict the time it will take the average student who has typing speed of 72 words per minute to learn the word processing program. So, ang speed natin dito is x and the time is y. Then, ang student dito is 1, 2, 3, 4, 5, 6. So, there will be 6 students. So, yung speed dito is yung 45 ay siya yung words per minute. Then, yung 85, yung natutunan niya word processing program within 85 hours. Then, ano yung tanong dito? So, ang tinatanong dito, kung merong speed na 72 words per minute, then ano naman daw yung time that it will take from the average student? So, ang kailangan natin ditong malaman is yung y. So, sa table na to, yung speed yung at time dito yung nakita natin kanina sa table. Then, yung x squared, so x squared lang natin dito yung 45 sa speed. So, 45 times 45 will be 2,225 and ganun din sa the rest. So, sa x and y dito sa end of the table, so, i-times din natin yung 45 multiply by 85. So, the answer would be 3,825. So, para makuha yung total nito, ipag-add lang natin yung submission of x. So, the total of 340. So, ganun din sa submission of y, 443. Submission of x squared, 19,824. And sa submission of x and y will be 24,594. So, sa pag-compute, ang una muna natin gagamitin is itong a. So, submission of y times submission of x squared minus submission of x times submission of xy or all over. And so, yung n dito yung number of student. Submission of x squared minus submission of x quantity 2. Then, the summation of y will be 433 times 14,824. Ito yung summation of x squared. So, i-minus natin sa summation of x, yung 340. Submission of xy, 24,594 all over. So, yung 6 kasi 6 students. Then, times x squared, 9,824. Minus 340 squared. At yun yung submission of x squared. So, the answer for A will be 125.62. Then, para mas bibilis nating makompute, kailangan nating gumamit ng calculator. Next formula, B is equals to 6 times 24,594 minus 340 times 443 all over 6 times 9,824 minus 340 squared. So the answer will be negative 0.1. Then gagamit din tayo ng equation y is equals to a plus bx. Y is equals to 125.62 plus minus 0.91. So, para maging negative to, so dun sa b, negative siya. So, gagawin natin siyang negative na. Kaya maging y is equals to 125.62 minus 0.91x. So, y is equals to 125.62 minus 0.91 times 72. So, the answer yung y natin dito is 60.1 hours.
For today, I will discuss the assumption of linear regression equation. Simple linear regression is a parametric test, meaning that it makes certain assumptions about the data. The assumptions are homogeneity or variance, homoscedasticity, the size of the error in our prediction doesn't change significantly across the values of the independent variable. Independent of observations. The observations in the data set were collected using statistically valid sampling methods, and there are no hidden relationships among the observations. Normality. The data follows a normal distribution. Linear regressions makes one additional assumptions. The relationships between the independent and the independent variable is linear. The line of the best fits through the data points in a straight line rather than a curve or some sort of grouping factor. If your data do not meet the assumptions of homogeneity or normality, you have been able to use a non-parametric test instead, such as a Spearman rank test. Example, data that doesn't meet the assumptions. You think there is a linear relationship between cured meet assumption and the incidence of rectal cancer in the US. However, you find that much more data has been collected at high rates of meat consumption than at low rates of meat consumption, with the results that there is much more variation in estimate of cancer rates at a low range than the high range because the data violate the assumptions of homogeneity. It doesn't work for regression, but you perform a Spearman rock test instead. If your data violate the assumption of independence of observations, if observations are repeated over time, you may be able to perform a linear mixed effects model that accounts for the additional structure in the data. That's all.